Alright, let's tackle this problem before my cats realize what I'm doing and they try to jump on the keyboard. So, Susan has an IRA with an APR of 6.75%. She started the IRA at age 30 and deposits $200 per month. How much will her IRA contain when she retires at age 65? Compare this amount with her total deposits made over the time period. So let's go through and pull out the important information, like the fact that this is an IRA. We have an APR of 6.75%. We have two ages given, age 30 and 65, so that deals with time. We got deposits, regular deposits of $200, and it's done every month. And we're looking to figure out how much she's going to have. So if we pull all that key info out, we have an IRA, and that means savings plan formula is going to be needed. And if that's something you weren't aware of, you can always Google what is an IRA or something. IRA, what is that? And you can see IRA is a savings plan. You can also flip through your textbook, your notes, and of course you can go to the SSE's math section. I'm going to go to the QR page, chapter 4. Chapter 4, there we go. And we have some examples about savings plan formula and a few other videos like this one. And we also, on the notes and examples page, a few different problems up here, but we have the chapter 4 formulas and notes. Now this first page is full of the variables that you're going to want to know. Definitely take a look at those. For this video, we're going to go right through and find the formula we need. Now it's a savings plan, so let's look for those keywords in here. Savings plan, savings plan. Savings plans, back chapter 4C. Oh, there it is. There's an IRA right there. Tells us that it's the right category. So if you keep going, the formula are going to be not the formula. The formula aren't highlighted, but the beginning of the formula list is highlighted. So the chapter 4C formulas are starting here, and this is the savings plan balance when regular payments are made. A stands for the future value, yada yada yada. So this is the formula we're going to use. Let's bring that in. Okay, so A stands for the future value. We don't have to plug that in because that's what we're trying to solve for. So PMT is the payment or the deposit amount. Susan's is 200. APR is the annual percentage rate. For these formulas, it has to be in a decimal. So for us, 6.75% turns into 0.0675. N is either the compounding periods per year or the deposits per year. And in this case, Susan is doing it monthly, and there are 12 months in a year. So N is 12. A Y stands for the number of years. And because Susan started at age 30, and we're calculating up until 65, the years must be 35. So let's go ahead and plug all of these into our formula. First, PMT is 200. APR, that pops up twice in the formula. On ours is 0.0675. N pops up in 3 different places. Ours is 12. And finally, Y is 35. So I'm going to go ahead and I'm going to open up my favorite scientific calculator. I'm going to go to, not that, that's me spelling it wrong, Desmos Scientific. And I'm going to type in what I have in my formula right into Desmos. So let me see if I can get these sort of side by side. Let's just scoot this over here. There we go. Actually, that works just fine. Okay, so let's type it in. So 200 times, I got this big jumbo fraction, so I'm going to press this A over B button for a fraction. In my fraction, the first thing I see is parentheses, then a 1, then a plus. Then I actually see another fraction, so I can do that again. The top of it is 0.0675. And I can just click down here to get to the denominator. And then when you're done entering in the denominator for fraction, you can either click off to the side or you can use this right arrow key. I like this right arrow key. And still following what we have on our formula here. I gotta close off my parentheses. And then next up I have an exponent, 12 times 35. So I'm gonna go ahead and use this a to the power of b button. This is my exponent button. And this is a little tricky when you have more than one number as an exponent. We have 12 times 35, more than one number. I am not going to say I'm a Desmos expert, but I do know that it helps if you use parentheses for this kind of thing. So even though the original formula that I showed on screen for this savings plan didn't show parentheses, you're going to find it helps. So just try and keep that in mind. All right, so back to the actual formula. We did our 12 times 35. Next up, we have to drop out of the exponent. So to do that, we're going to press that right arrow button. And we're going to do -1. So far, the top's looking pretty good, looking pretty similar to what we got, which is what we want. Tap down here to finish it up. The denominator of the big giant fraction is actually another fraction. We'll just type that in again. In the bottom, there's the 12. And the answer will automatically show up over here on the right. So it looks like if we calculate this all out, if Susan deposits $200 every month for 35 years in this particular account, she's going to end up with $339,000, no, $339,463.45 if we round it. So here's our calculation, and then we probably want to round to the nearest cent, so $339,463.45. Now, when I'm doing a word problem, I read the question more than once, for sure. I read it once to get the feel for what's going on, read another time to get the important information, and before I finish, and I think I'm done, I always go back to make sure I actually am done. So, Susan has an IRA with an APR of 6.75%. Oops, sorry. She started the IRA at age 30, deposits $200 per month. How much will her IRA contain when she retires at age 65? Compare this amount with her total deposits made over the time period. So what we did is we used the savings plan formula to calculate how much her IRA would contain. Cool. What we have not done yet is calculate her total deposits made over the time period. That's still missing. So let's calculate that. Then we have to do some comparing, but we'll get there when we get there. So Susan deposits $200 every month for 35 years. $200, 12 times a year, right? 12 months in a year, for 35 years means her total deposits add up to, and our calculations are 200 times 12 times 25. You can grab a calculator and do that. Just double check my math if you'd like. Oh, not 25, 35. Definitely double check my math if you want to. Can I fix that? Hold on. I'll fix that. Okay, there we go. Fixed it. 200 times 12 times 35, 35 this time, is $84,000. You know what? I'm pretty sure I got that right, but since I typed it wrong the first time, there's no harm in double checking calculations. So 200 times 12 times 35, 84,000. Okay. So those were her total deposits. Now just double checking the question. How much will her IRA contain? We know that. Compare this amount with her total deposits. We know that. So we know what the IRA contains, the $339,000. We know her total deposits are $84,000, but we need to compare them. We can't just stop there. So let's compare. So Susan's IRA contains $339,463.45, but she only actually deposited $84,000. So the comparison, the difference between these two values is equal to the interest earned. So we can take the amount we got from our first formula, $39,463.45, and we can subtract the actual deposit she made of $84,000, and she got a whopping $255,463.45 worth of interest. That's actually pretty cool. we can go a little further than just finding out how much interest she earned. We can calculate what percentage of her account is purely interest. Remember, interest is the money that the bank essentially pays you for using them as your bank. So we can calculate what percentage is just interest if we divide it, the interest amount, by the total account balance, and then we can multiply by 100 to get it into percent form. Let me show you. So this number here is her interest divided by the grand total in the account, and then multiplied by 100. I wrote down 75% last time, round to the nearest whole. Let's double check that. Let's double check. So here's the interest she earned. 463.45. Divide that by the grand total. 339,463.45. I'm just gonna use my right arrow to get out of there. And then multiply by 100. Did I get it right? There we go. 75.25, blah, blah, blah. But you'll see that I made a note. 75% rounded to the nearest whole. So after 35 years, Susan not only has over $300,000, but 75% of that money is money that she earned just by leaving it in the bank. She didn't have to put that money out of her own pocket. It's pretty sweet. So to finalize this question, I'm gonna write my final answer in a couple of complete sentences. So this is how I personally would word it. You can absolutely word it other ways, and in fact, I encourage you to do so. So I came to the conclusion that if Susan deposits $200 every month for 35 years in the IRA described, then she will have $339,463.45. She will have deposited a total of $84,000 over that time period, meaning the account will have, I should say accrued, another spelling error, accrued $255,460.45 in interest. The interest earned composed about 75% of the total in the account. Of Susan's retirement money, only 25% came from her own pocket. So we have done everything now. I can double check or triple check that question to make sure I've done it all. I used all the right numbers. I did IRA, which is a savings account. I figured out how much would be in the savings account. I then compared this to her total deposits. And then I put everything in a nice, neat sentence, or a couple sentences, and we're all done. What I find really interesting about this problem is not how much she has. She got a pretty good chunk of change there. That's really nice. But she only actually deposited such a small percent. Only 25% of that money is actually money she deposited. The rest of it was earned money from using this particular bank account. That is really cool to me. But then again, I'm the math nerd, so a lot of weird things are cool to me. But we'll call it good for this question. I will leave the resources that I showed on the screen in the description, and I wish you the best of luck.